that's it. So yeah, Motion Perfect comes in with the capability to incorporate the IEC-61131-3 languages. One of them is ladder logics. The other three is structured text, functional block diagram, sequential function chart, and the other one, our own language, True Basic. So they all work together, but they will come in with True Basic. If you have a look at the Motion Perfect, it's just gonna comes under the header of program, whilst the other IEC-61131-3 will come in under the a separate tasks. So later on, we can see how it pans out using the ladder logic. So I don't know if I'm sure that you're quite familiar with the ladder logic yourself, or if not, it's not a problem. So ladder logic is designed, I believe it's coming from the field to the development. So this is the schematic that field people know and understand, and so they come up with that's life, and that's so that's the power supply, and the flow goes from the top to the bottom. So contacts, and you've got coils to activate. So it's very easy to understand if they sort of come up from the same platform or same structure. So the ladder logic is built to do so, which is just that. So if you imagine that, and then you rotate like that, 90 degrees counterclockwise, you have ladder logics. Yeah. So in a ladder logic, you have context, just like previously we have context on the top, context, and then you got coils. You got context, and you got coils. You got context normally closed, normally open, or you have timers. Back then they have relays and all that, but in the program we have timers. So it's very easy to adopt for field people. That's why I think that's probably if you're talking to any field people, they would prefer to use ladder logics than True Basics. But I can guarantee you, give them 2 weeks, they will definitely prefer True Basic. It's a lot easier, it's a lot simpler, a lot makes more sense. I'm myself coming from ladder logic person, and I've been here for over a month, and I was like, that's it. I'm not going back to ladder logic. But again, Motion Perfect is supporting that. Well, ladder logic is sort of lower language, but it's a diagram. It's a schematic language. But I would consider it as a lower language, like structured text or assembly in this case. But True Basic is more a high level programming language, so it's more like using human recognized syntax. While this is the case, do this. If this, then do that. Yeah, so it's easier that way. But apart from that, before I was studying ladder logics, I was also doing C programming, Java, and all that. So it's more sort of like coming back to the root, really. So anyway, so in the ladder toolbar, you got this toolbars. So in your Motion Perfect, you can actually, let's go through it together, and then we'll come back to the slide. Now, if you can go through with me, you have your programs there, and then if you right click and then you write new, it really depends on how you want to structure it. So in my case, on the left pane, navigation pane here, I've already created IEC task 1, IEC task 2. So what it does is that since Motion Perfect separated into different processes that you can assign, say task 1 you run on process 20, task 2 you run on process 21, or just leave it to the controllers to decide, it's fine. So individual tasks can run simultaneously. Yeah. So it really depends on your application demand, that whether you wanna separate into 1, 2 tasks, 3 tasks. It really depends, or just keep it simple, 1 task. Yeah. So in order to do so, you go to add new program, and then on here you have this 61131-3 task, and then you choose your preferred language, and then you name the task. For example, in this case, I'm gonna put IEC. Sorry, I just gotta do that first. So that's I'm making the task IEC task 3, for example. Click OK. That. So that's created. So task is a container for your program, for your 61131-3 programs. It can be anything, just like here I mix between functional block diagrams, ladder logics, SFC, or structured text. They work perfectly fine. And then once you create a group of this, then you can obviously tell which one to run first, because at the end of the day, even in the for say in a very advanced processor, it's all sequential in a way. So you define which one that will run first by managing the order on this window. So again, it goes from here, right click on the task, and then program execution order. Then you say the order. Right, so here I have created the ladder logic, but let's focus on the one that we just created. I want to add a new program which is named, I would probably say main, and then that's a ladder diagram, and it's a type of main program, and then I just add. Now you've got the ladder logic editor, where you can see that these are your toolbox, that we're going to go back to the slide for what this means. And then some of the functions here are context related to what you activate or what you select. So if I go back to the slide there, so this is a zoomed in version of the context. I know it's quite small on the Motion Perfect. So that one says insert contact before, insert contact after, in reference to the highlighted part of the rung. So if you're familiar with it, every bit of this is called a rung, just like a ladder. There are several rungs. Yeah. So say for example, if we want to put, say, insert contact before, we put that, and then a pop-up comes in saying that, okay, what do you want me to assign this contact as a variable name? Say, I would just say trial 1. Trial 1, and then I just click enter, and then it come up. It knows that it has not got a variable by the name trial 1. So a pop-up comes in and say, hey, I don't recognize this trial 1. What type is it? You've got to tell me. Okay, it's a bool, because contact is a bool, whether it's on or off. And then where do I want to put it as a scope? So I can put it as a task scope, meaning that between programs you can reference to the same variable. You can put it as a retain. That means once power is lost, then the value of it retains, doesn't change. Or you can put it as a global. Then it sits above the higher of a task, so all other tasks can actually see it. Now, other tasks can see it, but doesn't mean that the HMI can see it. Now, you just have to be careful with that. So if there's something that sits above global, which is the probably the VR is sort of global, more global to it. So the way it's structured is that you've got the HMI variables, you've got the controllers variables. So the global sits over here, but the HMI cannot see it unless if you bind it to the middleman, which is called the VR. All the variables that you put into or you bind into the VR on the ladder logic, this is specific for ladder logic and 61131, is visible to the HMI. Okay.
Is it also visible to the basic programs as well?
I believe if you put it into global, I believe that it is visible to the basic program. Yes.
Otherwise, it's not.
Otherwise, it's not. It's just within the scope. Mm-hmm. Yeah. There is. I mean, I know a programming paradigm says that just keep it to the necessity of it. I mean, some people just want to just give it global. You know, you'll never know. They might just need it. But in this case, if you want to keep it global, there's a limitation to it that if it's global to the HMI as well, then you've got to bind every single one of them to the VR. And the trouble is that we still haven't got a way to say, okay, which VR that we have been using. So you have to be really careful because you can't really detect, VR 120, say, but once your program gets bigger, you can lose track of which VRs that you've been using. So you will be overwriting the one that you've been using for another task in another program, for example. So do use it sparingly with cautious. So in a way that just keep it to the scope that you want it to be. If you think that this variable it will never go beyond this program, so just keep it local. Yeah, and that also saves memory allocation as well, in a way, because when it goes out, when the program pointer goes out of the scope, it will just not being there anymore or being processed anymore. So the memory can be allocated for other variables. So anyway, so what type is it? It is a Boolean, and where do you want to? What scope is it? Well, let's keep it in the main. Okay, yes, there you go. So you come up with a trial there. There's your context, and this is the coil. Now the coil again is what you want to activate. Ideally an output or a temporary output, if you like. So if you've got temporary results that you want to keep, and then you activate an output later down below the rungs, then you can create another variable. Let's say in this case I want to put it as a temp one. Again, what is it? Okay, keep it bool, keep it main, and that's it. So so if I just synchronize that, so that's happy, there's no error detected, and that should be okay. And so that we have created our first rung in ladder. So it really is that simple. No fuss. They have the abbreviation KISS, keep it super simple. Some say keep it simple stupid. I don't like it. I tend to keep it super simple. So it is what it is. So no, it's not really that complicated. So these are like insert context, context before, after. So like I said, if we highlight this one and then context after, so that means the context will be situated after that, just like that. Yeah, but I'll delete that. And then we have insert contact parallel. So if you highlight that and then contact parallel, it will create right below it. So if you want to that like that, so that's typically in a trio basic, it will be, it's either trial 1 or temp 1 activate temp 1. This sort of configuration normally in ladder logic, it could be, it's a latch situation. Once trial 1 is on, then temp 1 will be on all the time, unless you put, normally I would put a normally closed context here, say if I put another context before the coil, and then I would say trial 1 again. But if I press, now this is the cool stuff, if I press space bar, it will become a normally closed. Or if I press space bar again, it becomes a positive trigger or a negative trigger. So you can change it just by clicking the space bar. So so in this case, if it's like a one shot type of thingy, but this obviously will not work, because when that one is on, that one is off. So
Yeah.
so I will just
Change the name. Yeah.
trial 2 again. I don't know, trial 2. Put it there. There you go. So probably it's easy if I just now if I want to see all the variables that I have created, I can go to here, open IEC-611 variables. Now it opens up another window here, and it goes, and it's structured the way where the scope is. So we have the program main, and now we have that. Now I want to rename this. Just gonna right click and rename. I'm gonna say start. Probably better yet. Start push button. So start push button, and then this one is stop push button, and then this one would be motor 1. So in this case, this is typical starting ladder logic. So if someone presses start but not a stop, it will energize motor 1 as long as the stop push button is not pressed. Motor 1 will always energize, sort of re-energize itself, so the motor 1 will have the power continuously. The reason for stop push button there is normally closed, because physically stop push button is normally closed button. I think it's actually part of the requirements of safety requirements. It has to be normally closed, because if there's no power, then it has to stop in that situation. So that's it. We just created our first run in ladder logics. It's very simple, and if to get to know the functionality more of this buttons over here, now here you can select variable. For example, if you want to change that, you can just select variable. That's the same pop-up that we just that we have known before. And then this is the variables, which is that window over there. And then now this one is types. So you can create types. Now in my experience, it's been very useful that, say for example, in a factory, that they want to create recipes, sort of like they want to create a structure called recipe that contains the name of a recipe, the value of the recipe, and then say
You find the parameters for the different
yeah,
of the productions.
yeah, exactly. So let's create this another structure. So you insert a new type. I would say recipe. The type is called recipe, and then I want to add a variable. So as you can see, the tree structure already said, oh, recipe contains what? Okay, name. It's a string. And then you can, I don't think that you can bind the structure here, but it's more controlled in the variable window. So if I just go back, so it goes beyond.
But Boolean, I think.
Oh, sorry, it should be string. String.
It doesn't.
Does it not? There's string there.
You need to choose the object.
There you go. And then add. So active, let's say. Is it active or not? It's Boolean. Okay. And then I want to say value, which is single integer. Yeah. And then once that, you click save. It will compile. And then it will try to save it. I'll just save in the say desktop. You can put it in your project folder, obviously, ideally. So save that.
You need to even name.
Oh, sorry, RCP. Yeah, there you go. And it saves that as an XML. Now, if you do want to get clever and then you don't want to go through the same process, you can just change the XML and then add more structures to it. I'm sure it will work as well. So that's done. So now if we want to create a variable, so we have created a structure there called RCP. Yeah. So we create a variable. So if I want to say started, but if the recipe is not active, don't start motor 1. I can change that, and then I change that recipe 1. Now it will say that I don't know recipe 1. What is recipe 1? Recipe 1 is type recipe. So if I go there, R, there you go. So our structure has been recognized as a type, so we can select it. Where is it? Do you want it? In main, fine. But obviously recipe 1 is a structure, so we need to come up with the right type for this contact. So recipe 1 dot, and then you have options there. I want to say, is it active or not? Yeah. And you can expand if it comes with dot. If it's not big enough, you can expand that. So this is good for someone who thinks that, oh, this is too small. There you go, that's better. Yeah. So this is saying that, okay, start it only when it's active. So let's compile it. Everything's happy, no problem. There you go. But if, say, for example, you just say recipe 1, it will not say anything at the moment, but I would expect if during the compilation it should error, saying that, hang on a minute, the contact should be a Boolean. You're not giving me a Boolean here. Okay, so let's correct that. Just put it there. Alright, so that's pretty much the ladder logic. And we're going back to the toolbar. So these are the function block instructions. Another one is insert new rung, insert coil. For the ladder logic itself, we've got the whole library with the function blocks. So in order to do so, we activate this toolbox window. Click it. So now you have the whole, if I just close this, so the whole, I think I prefer the variables on this side. Right, so I got the toolbox on that side. Now, so I have all the instructions that I can drag and drop from the library. So for example, the second thing that is more important than context and coils are timers in ladder logics. So if I just wanted to say timer on, So I search it. Just thinking now. All right, timer on. So I know timer on is a function that gives a delay. Say, if in order to prevent spurious signals, you want to make sure that someone press start really intend to press start, or someone press stop really intend to press stop. So you put a debounce, which normally activates using timer in program. So let's say you use the delay here, and then you drag it, since it's a function block and it recognizes, oh, this is a new function block, you gotta give me a name to it. Okay, so it comes up with a variable window. I would say timer 1 or TM1, probably TM1. And then since it knows that you just drag a timer across, then it will automatically assign the type as T-on. So you're just going to go and click yes, and that's it. Now with the timer, you have options of this is preset time, and then this is elapsed time. So you can use this to so with a timer, you obviously want to set what's the timer. Okay, 1 second. So you have the format T hash 1 second. Yes, that's it. It says 1 second. And then if you wanna store the elapsed time somewhere, you can store it somewhere by creating a variable there, or you can just reference it. Say in this case, if I want to create another run and say if tm1 dots, what is it, elapsed time, or the result, probably the result because we were expecting boolean, so you can actually reference to it, to the result of the timer. So once this is saying that, okay, if timer 1 is done, I want to know, or I'll say it then, time is up. Yeah, so really simple. It's meant to be simple, ladder logic, but once you get to know it, it's very easy. You just need to know the functions, the syntax, and our help file is quite useful. But sometimes some of the functions are not really there, not really hitting it. But I think the basic is there. So that is pretty much on the toolbar. Select function, we have done that. So okay, so with the select function, if you want to change this to another function, you just choose that select function and it will change it. Instead of a timer on, then you want a timer off, for example. So that delays and look for the negative trigger. So it really is that simple. So parallel, it's pretty much self-explanatory. So that's the toolbox. It will pop up the toolbox window that you can choose whatever that you want to put in. So any idea on how to blink an output? This is like pretty much hello world in anything really. There you go, probably so.
Which one is that? The timer on, timer off?
Yeah, you can do that. You can do. Okay, that's now. Yesterday I was like doing this exercise, and I put the old-fashioned way of doing it, and then
is there any toggle?
Pardon?
Is there any toggle function?
I'm getting to that. Yes. So here we go. Here we go. Now, the old-fashioned way is to do it like this. That you divide it into 500 on, 500 off. So 500 on with it. Both of them are using T on, or you can use a T off in the example. So this is the old way. So as soon as that starts, that's just gonna see T2 whether it's done or not. Obviously it's not done initially, then it's going to start for, in this case it's 250 on, 250 off. So it'll be half second cycle. And then that's going to time out, and then that's going to activate T1 done and output 8. But that T2 is referencing that. As soon as that done, it starts the off bit, yeah. And then so we're just looking at the results of output 8, which is going to give you half a second timer blink. So if I say if I want to change it to so it's a more visible, I would probably change it to 449. Now there's a reason why I give 449 here, which I'm going to come to in a second, in a minute. So I'm going to put that. Now I'm just going to change this as well. We're not going to touch the using blink function yet. Right. So if I run this, it's this thing. Now IEC-61131 comes up with a license, isn't it, Stefan?
Actually, it's a feature code.
Yeah.
So you have to buy certain feature code to activate access. So, like for example, this controller is a 405 controller. So it's a 5-axis. You can use it as a 5-axis servo or 4-axis stepper. Alright. But so if you want, but the initial they give is only 2-axis and or something, I mean purchase or something like that. So the IEC code is actually is not built in. You can use it for an hour for free, but you have to activate the feature code.
Which is why that error keeps coming on
exactly.
the screen.
Yes, exactly. So you just have to reset the controller and fine. But it's if you really need that code, you can. We can give it to you. You don't need to pay anything, but it's just we don't want everyone to activate this because we are paying IEC the license.
Right.
Exactly. Yeah.
So every time they activate this, we have to pay.
So this is saying my controller hasn't got the option or the ability to have this letter, but it is there. It's only that I need to reset it or turn it on and turn it back, turn it off and turn it back on.
Then you get another one.
Then you get another hour. So let me just do that. Right. Okay. So I have turn off and turn on. So we have that, and then I've pressed play, and then so if I want to activate that, this is a tag, a variable, which is currently false. So if I want to activate that, I just double click it and say, okay, what value do you want? I want it to be true. So now you see it's flashing now, isn't it? Yeah. So you're flashing output 8 for, sorry, this is different time on and off. This should be 449.
This is all in the controller, not.
This is in the controller, not in the in Motion Perfect.
Is it possible to simulate it under Motion Perfect also?
You can use a simulator, controller simulator, yeah.
It is the IEC. I never use it.
Yeah.
That's my question.
So if I do that again, so now you're gonna have 500 millisecond on, 500 millisecond off. You would think now, why am I putting it like 449 here? This should be 499. Now, initially I was thinking, okay, I can probably put 500 on and 500 off. That's going to be 1 second, isn't it? So like that. So if I play it again, run it, and then run my tag 1. So now
1 second.
That is 1 second now, and then when I was doing and then looking through the function blocks, and I found this blink, which is the second option, which is very simple to make an output blink, and that is the function block. It's called blink.
So-
Yeah. So instead of you just use the whole thing, you just blink. That's already in the block. Yeah. So, but now, since I've already done that, and I all my life I know that works to create 500 millisecond on, 500 millisecond off, and then I use this blink, and I energize the output, which is output 8 and output 9 here, and I can see that they're actually not really synchronized. If you have a look at now as well, you can see that this is leading than that.
Exactly.
And then I was like, why is that? Why is that? And then I just realized that there is an execution time. The way a ladder logic goes is it scans it and then go to the top. Scans it, go to the top. With this blink, it just scanned once and then that process goes somewhere. It didn't really have to go through the process again. So that's why this is pure 1 second clock. Well, this one, you got to go through that again.
Affected by the,
Yeah,
the process.
exactly.
Program.
It's
And the
affected.
program getting more. I mean, getting.
It's
longer.
affected by the scan time. Yeah, it goes through there, and then so if the scan time is 10 millisecond, you can really see, oh, this is gapping way too far. Now, that I only came to that conclusion because Jeff told me that you can actually manage the scan time here. So if you go to the IEC, right click, and you can actually see the executable info here. So here you can see the program cycle time is 0 millisecond, but the maximum cycle time is 1 millisecond. So there's a lag in between of 1 millisecond, but since you know it builds up 1 millisecond and then 100 click, it will be 100 millisecond. Yeah. So that's why originally I made that program. I was like, oh, okay. So if I made this 549, sorry, 44499, and this one is 499 as well. Now that would fix the issue, but you don't know until you actually do it. And then on the IEC task, you can set up what's the scan time. You can say just run it as fast as possible, but there will be lag. If it's something that you can ignore, it's fine. Yeah. But if it's something that you can't ignore, just use blink. Yeah, it's more precise. So you can trigger it. So if you trigger it like 10 millisecond, it's technically a periodic task. Every 10 milliseconds, execute. Every 10 milliseconds, execute.
Time-based.
Time-based, yeah. While with this one, as soon as it gets to the bottom, run it again, yeah. So we'll just do that, and then when I run it, now it should be perfect. It should be blinking exactly the same time. Yeah.
Okay.
Yeah, a few bits of text, but the thing is, 1 millisecond for a process can be quite detrimental when it comes to, say, a period of time. Yeah. So with a function block, what I'm trying to say here is that if there's a function block, use function blocks, because it's been tested, it's been, you know, verified. If not, then you can come up with yourself with your own code. All right. So that's a function block.
Show some trio function blocks.
There is some trio function blocks as well.
I want to ask about.
Trio there. To be honest, I have not used this ever in ladder logic. But like this datum is equivalent to trio basic datum.
So all the trio basic commands are in the function.
Are in
Not
there.
all of them.
Yeah.
Depending on the version.
So
isn't it?
whatever you can see is
Yeah.
from the trio
Three
basic.
basic.
See, if you want to create
Write
a
it to
program,
the
you can use this.
Yeah.
If you understand trio basic, then you can understand this easily, and then you can come up with your own
Yeah.
move apps.
Move apps, like the one if you say you want to move an axis. So you got move apps and all that, so it's all there. And what I like about this toolbar, that's why I always activate the toolbox there, because it comes on with this help. So what is expected of the input, like in, out, what's the type, and also as soon as you drag it, say for example there, you also have the programming help access to there, well, which is not related to toolbox, but in the toolbox it's very handy. Like, oh, okay, so if I know, oh, move apps, just gonna hover it, okay, that's what I need. Because sometimes you do come across problems where the type is not exactly the right type for the input or output. Right. So that's pretty much it. Any questions?